Hi folks, this is the 8th problem of the DSA series, so let's get started. It says given an array of integers, return the length of the longest consecutive sequence of elements that can be formed. A consecutive sequence is a sequence of elements in which each element is exactly one greater than the previous element. The elements do not have to be consecutive in the original array. Okay, so let's take this array for an example. Here a consecutive sequence that we can find is 2, 3, 4, 5. Okay, so the sequence in which if we increment 1 to an element, another element can be, we can find another element. For example, 2 plus 1 3, 3 plus 1 4, 4 plus 1 5. So this is a consecutive sequence, right? And the length of this consecutive sequence is 4, that's why we returned 4. Okay, note one more thing, here 4 is being repeated twice, but we'll consider it only once. That is, if an element is being repeated more than once, we'll consider it only for one time. Okay, and another thing is, let's say if this array is longer with elements like 21, 22, 23, 24, then you can find another consecutive sequence. One consecutive sequence is this, another can be 20, 21, 22, 23, 24. So this second consecutive sequence, which is starting from 20, is of length 5, right? And this consecutive sequence is of length 4. So in this case, the output will be 5, right? If this could be the case, right? Because we have to return the longest consecutive sequence, right? So I hope you understand what we got to do. So yeah, let's do it. One more thing, it says you must write an algorithm that runs in O of n time. Okay, that we can do, but first let me show you another solution which takes n log n time, right? Then we'll write another algorithm that will do this in O of n time, right? So it will make you understand better. Okay, so for that we can write const, we'll sort this array, sorted nums is equals to nums dot sort sorry b, so it will make this array sorted array in increasing order. Now we can have, we want the longest, right? The longest sequence, so let's take longest is equals to 1. Now let's loop over this array for let I equals to 0, I smaller than sorted nums dot length minus 1. Why sorted, y dot length length, okay. Why length minus 1? Because we'll compare an element at the ith index to the element at ith plus 1 index. Okay, so that's why we don't need the whole length. Okay, because we'll compare the second last element to the last element and it will do it, right? So let's do it. So we'll say let if sorted nums I is equals to sorted nums I plus 1. For example, here we have 4, it is being repeated twice. If the element is equal, and here we have like sorted array, so this will give us sorted ones, this will give us, just so you know, it will give us 2, so it will give us, I'm writing sorted array here so that you can reference it, 2, 3, 4, 4, 5, 10 and 20. Okay, so this will see if I element at ith index is equals to element at I plus 1 index, that is, it will compare these two, and if this is so, it will continue this loop, that is, it will come back again at the start of the loop. However, if it's not the case, then we'll simply say if we add 1 in the element that is present at the ith index, then if it is equal to the sorted nums I plus 1, that the element present at the ith plus 1 index, then in that case simply do let's write a counter here as well, again from 1, increment the counter. If this isn't the case, what should you do? What should we do is we'll simply reset the counter to 1. Okay. Now here there might be two sequences that I just show you. There can be 2, 3, 4, 5, then 20, 21, 22, 23, 24. So we have to store the counter somewhere. Okay. So here we can say if counter is greater than longest, in the longest we'll store the longest one. We can simply say longest is equals to counter, right? After counter plus plus was, it will check this, and if the sequence is being broken, counter is being reset to 1. Okay, I hope you understand how this is working. Now after the loop we will simply return the longest, and this should work. Let's check this if it's working or not. Let's give it this comment out this, let me give it this nums, and let's see. Okay, so it is giving us 4, it is working 2, 3, 4, 5. Let's add here 21, 22, 23, 24. Now it should give us 5. I'm just checking if this is working or not. Yes, it is giving us 5. So yeah, it's working. Okay, it's working. However, the time complexity of this n log n, simply because sorted, this time complexity of sorting these numbers is n log n. Now let me write another function with time complexity of n. Okay, O of n. So I'll say this consecutive sequence final. Here it will again take nums array. Now here we'll use sets. What a set is? Set is simply an array with unique elements. There is no element will be repeated. If there is any repetition, it will be thrown out. That element will be thrown out. The repetition is thrown out. Only one copy will be kept. Okay. So let's take a set. Const num set is equals to new set, and we can directly make a set of from an array by doing this. Okay. So it will give us a set, and it says, so this will give us, so just for your reference, it will give us 22, 4, 10, 3, 5, right? 4 will be there only once. So this is a set. Now again take longest is equals to 1, and let's map over the set for let. In order to map over the set, we can't do like let I equals to 0, I plus plus. We won't do that. We'll simply say let num of num set. Another good reason of using set is checking if an element is present in a set is an O of 1 operation, right? So let's say if we do, so what our technique here will be, will check if the element that we are mapping over, that we are getting, is the smallest one in the series. If it is the smallest one, then we'll check if this element plus one element exists, then that element plus the next element exists, then that element plus one element exists. So that will do. Okay. So first we'll find the smallest one. So for that we'll do if num set dot has num minus 1. If let's say if we came to 20, we'll see if 19 exists. So this is what the set will give us. So we'll say if 19 exists. For 2 we'll see if 1 exists. For 4 we'll check if 3 exists, right? So let's consider 20. It will check if 19 exists, right? If it doesn't exist, then this will be true. That means let's continue here. Then simply say let current frequency equals to 1, let current number, or current, we can say, yeah, current number is good, current num is equals to num. Okay, now here what we can do is we can simply have a while loop which will simply increment 1 in this element, right, in the smallest element, right. So in this case we let's say we'll simply say if, so let bear with me, understand what I'm doing. Num set dot has current num plus 1. If it has the next number, simply increment the current frequency by 1, simply increment the current number by 1. Okay, so for 20 it will come to 20, it will see, okay, so smaller than 19 doesn't exist, so it will come into here, and then in the while loop it will check if 21 exists, it doesn't exist, so it will exit the while loop and again come back to the for loop, and for 2 it will check if smaller than 2 exists, doesn't exist, so it will come here, then current frequency 1, current number is 2, then it will check if 2 plus 1 3 exists, so frequency will be then incremented by 2, current num will be 3. For 3 again it will check, then this while loop will go on. For 3 check if this exists, if it exists, increment the frequency, increment the number. If this exists, increment the frequency, increment the number. Then, right, so it will do this, right. And then after this while loop we can simply say the maximum, right. We can simply say after this we'll do longest is equals to current frequency. We can't say if the longest is equals to current frequency, we got a check, so we'll do longest is equals to, let's do math, simply math dot max, and here we can say give it longest and as well as current frequency, whichever is the greater, it will return that thing, right. And then after the loop here we'll return the longest. Let's see if it's working. Let's do con final. Let's see if it's working. Yep, it returned 4, so it is kind of working. So yeah, these are the two methods here. The time complexity due to sorting, time complexity was n log n, and here the time complexity is O of n. You might say the time complexity is O of n square because of this iteration and this while iteration, but it is actually not, right, because this while is taking the smallest number only, right. For example, it won't work for this and this, it will only work for 2, right, and for 20 as well it won't work, right. So this, yeah, you understood, no. So this is the only iteration that is being counted, so it has a time complexity of O of n and a space complexity of O of n as well because of this set, right. So yeah, this is all for today. Thanks for watching.